Good evening, students. Today we will start wave optics. Chapter 10, NCRT, 12th, Part 2. We have studied about the corpuscular model of light. We have derived the Snell's law. In 1978, the Dutch physicist Hugyen put forward the theory of wave theory of light. And this wave model of light we will discuss in this chapter. The wave model will satisfactorily explain the phenomena of reflection and refraction, and however we all know that in refraction the wave bends towards the normal or away from the normal, okay, depend on the speed of light in the second medium. And this is in the contradiction to the prediction made by using the corpuscular model of light. And the experiments shows that the speed of light in water is less than the speed of light in air, and that is confirming the prediction of wave model. Initially, the scientist does not accepted this wave theory, but later on experiments, on the basis of experiments, they approved it. So today we will start with Hugyen's principle. So as per the Hugyen principle, each point of the wave front is the source of a secondary disturbance and the wavelets emanating from these points spread out in all direction with the speed of wave. To understand this principle, first we will study about wavefront. What is wavefront? If we know what is wavefront, then only we can understand this theory completely, or this principle completely. See, what is wavefront? Suppose we have a small pool of water, a calm pool of water. If we drop a small stone on it, definitely there will be waves spreading out from the point of impact, and every point on the surface start oscillating with time. So if I am dropping a stone and there is a disturbance created, then there would be different waves, and these waves surface will be shown as circular rings on which the disturbance is traveling and the disturbance is maximum. Okay, so we can see the wave generating in water, and then this will be in the form of concentric circles. Wave is traveling in all the directions like this. So all points on these waves are oscillating in the same phase because they are at the same distance from the source, and this oscillates in the phase is called the wavefront. So the wavefront will be defined as a surface of constant phase, and the energy of the wave travels in a direction perpendicular to the wavefront. In this case of a pool of water, these waves are spherical waves and the source is point source. We take very small portion of the spheres and then we can consider them as a plane. So a plane wavefront can be denoted as follows. So now we will come back to the Hugyen principle. Now we know the wavefront. According to Hugyen principle, each point on these wavefront is the source of secondary disturbance. Okay, and the secondary disturbance and the wavelets from these points is spread out in all the direction with the speed of wave. So we can draw these further diagrams as follows. Let's say this is a wavefront. Source is down here, which is known as O, point O. We have one wavefront, then we have another secondary wave. We have second wavefront, then we have third wavefront. If we consider a single point on, let's say, second wavefront, we named it as A, then there is a very small secondary disturbance will be created out of this point, and this disturbance will spread out in all the direction like this as well as like this, and there would be n number of points on this each wavefront. It might be B or C, and the waves is spreading out in all the direction with the speed of the wave. So if you wish to determine the shape of wavefront, let's say the shape of wavefront at t equal to 2 will be a sphere of radius v2 from each point on the spherical wavefront. Spheres of the radius v2 from each point on the spherical wavefront. Where we represent the speed of wave. So we can get a new position at t equal to t0, and we can make again and again such type of wavefronts, and we can obtain the direction of traveling of wave. And Hugyen argued that the amplitude of the secondary wavelets is maximum in the forward direction and zero in the backward direction. Okay, by making this ad hoc assumption. This is the only one shortcoming of this model. Hugyen easily can explain the absence of back wave, but this assumption is not satisfactory. The absence of back wave is actually justified from the more rigorous wave theory, and we will discuss that in coming chapters. Okay, tomorrow we will discuss about, in next session we will discuss about diffraction and reflection of plane wave using Hugyen principles. Thank you.